Hi everyone, let us discuss this example. So in this example, we have multiple questions. We will solve all those problems one by one. Okay. So the basic thing is we have a vector field f of xyz which is defined in this way. First of all, we have to prove that the field is conservative. That means curl of f bar should be 0. So let us find curl of f bar. Okay. So let me consider curl of f bar, that means del cross f bar. So you know that how to find cross product, okay, of two vectors. That means we get its value by solving determinant I, j, k. So del is an operator having components deva by deva x, deva by deva y and deva by deva z. So that will be my second row. Okay, deva by deva x, deva by deva y and deva by deva z. Definition of f bar is this one. So what is first component? Y sin z, I should write here. Next x sin z and the last one is xy cos z. Let us solve the determinant. Okay, I. Product of these two, that means derivative of this one with respect to y. Okay, I will write it properly. So this is deva by deva y, deva by deva z. I should write x sin z and xy cos z. I will tell you what I am doing here. So we write a first entry here. After that, we will not consider corresponding row, corresponding column. So we will have this 2 by 2 matrix and we will find its determinant. After that, we write minus sign. Next entry j. Getting? So don't consider or ignore that corresponding row and column. So we'll have deva by deva x, deva by deva z, right? And y sin z, and I should write here xy cos z, okay? Plus k. Next entry, last entry. So ignore corresponding row and column. So we will have deva by deva x, deva by deva y, right? And we have y sin z here. And next one is x sin z. Okay, so in this way we solve this determinant, right? So let us go further. We have some space. Let us use. So this is equal to I. So you know well how to find 2 by 2 determinant. Derivative of this one with respect to y. X cos z is constant. Derivative of y is 1. So that's why we'll have x cos z. Let me write in bracket minus derivative of this function with respect to z. So x is constant, it will be as it is. Derivative of sin z is cos z. So x cos z again we get here minus j. Derivative of this function with respect to x, derivative of x is 1, remaining parts constant. So I will write y cos z, right? Minus derivative of this one with respect to z. Y is constant and derivative of sin z is cos z. So I should write here y cos z. Last plus k, okay, plus k. Derivative of this one with respect to x. Sin z is constant, will be as it is. Derivative of x is 1. So I should write sin z only minus derivative of this function with respect to y. Sin z is constant, derivative of y is 1. So you'll have sin z. So all brackets will be 0, getting? So x cos z minus x cos z 0. This one will be 0 and the last one will be 0. So basically we will have 0i plus 0j plus 0k. That means we have a 0 vector. Okay. So therefore what we get, del cross f bar is equal to 0. If curl of f bar is equal to 0, we say the field is conservative. So therefore we can declare therefore f bar is conservative. Okay. So in this way we proved that given field is conservative. So obviously after that we have a next question, find its potential function. Let us find its potential function, make a screenshot of it and then we will go further. So let us consider phi be a potential function of f bar. Okay, so maybe you are thinking what is potential function? See, when we have a scalar field phi such that f bar is equal to del phi, that means gradient of phi, then we say phi is a potential function of f bar. So f bar is already given to us, getting? So simply we have to find that potential function phi. Let us find. Let me put value of f bar here, which is y, what we have, y sin z, getting? Next x sin z. Next one is xy cos z, okay, is equal to del phi. You know the operator del. So deva phi by deva x, deva phi by deva y and deva phi by dabba z. We have written here both vectors are same, so that's why we can equate their components also. So therefore, let me write first component is equal to dabba phi by dabba x, which is equal to first component here y sine z. Okay. Second component dabba phi by dabba y, which is equal to second component here x sine z, and the last one will be dabba phi by dabba z is equal to xy cos z, right? Okay. So we have got partial derivatives of phi with respect to x, y, z. But what is our final target? Our target is to find the scalar field phi, getting? So let us integrate with respect to x. We have a derivative with respect to x. When we integrate with respect to x, derivative and integration will get cancelled to each other. Therefore, phi is equal to, I am integrating with respect to x, so it will be constant, getting, since there is no any x, so when we integrate we will have simply x into y sine z, getting, plus I should write psi 2 of yz. So you know that when we integrate, always we used to write c, which is a constant of integration. So when we integrate with respect to x, constant of integration can be a function of y and z, since y and z are also constant. So that's why I have written psi 2 of psi 1 of yz. It is better to write psi 1 of yz. Okay. So here I will repeat the procedure for the second function. Here we have a derivative with respect to y. So I should integrate with respect to x now, or y now. Okay. So when we integrate with respect to y, derivative and integration will get cancelled to each other and we will simply have phi. So here also in right hand side also we have to integrate with respect to y. But there is no y, so it's constant. When you integrate with respect to y, we will have y there. So that's why we'll have x, y will be there. X sine z will be as it is, since it is constant. Here I should write psi 2 of xz, since xz are constants, getting, for this one. So that's why constant of integration will be for function of x and z. Let us go further. This is derivative with respect to z. Obviously, I should integrate with respect to z now. X, y constant, I should write as it is. Integration of cos z with respect to z is sine z. So I should write here sine z. Can you tell me what I have to write there? Yes, now we have to write psi 3 of xy, since x and y are constant for the last integral. Okay. So therefore, let me write here, we have some space. Phi is equal to, we have to consider all these three values of phi we have to consider all together, and finally we write the expected phi. Xy sin z everywhere we have got, so I will copy only for one time. So phi is equal to xy sin z. If you have any additional function there, then also you can write here, but we have only one function xy sin z. I should write the constant of integration c now. Okay. So phi is equal to xy sin z plus c, which is the required potential function of f bar. Okay, make a screenshot of it, then we will go further. So the last point is calculate work done. Now we have to find work done. You know the formula of work done. W is equal to integration f bar dot dr bar. Getting? And what have they mentioned from point P to point Q, right? See, here we have already proved f bar is conservative, and we have seen if the field is conservative, line integral is independent on path. It depends only on its endpoint. So that's why value of this integration will also depend on P and Q only. Okay, so no need to worry. Any path you can take, you will have the fixed value. Okay, and final value. So this is equal to, let me solve it further, integration P to Q. But just now we have proved f bar has potential function phi, and f bar is equal to del phi dot dr bar. This is nothing but integration P to Q. We will have d phi here. Okay. So you know what is integration of d phi? Phi only. So let me write here. So which is equal to phi, right? And here P and Q. So after that I will put the values. Okay. So what is value of phi? We have got already x, y, sin z. This is value of phi. What is point P? We have 0, 0, 0. And what is point Q? We have pi, pi, pi. So you know that when we solve the integration, first we put upper limit, after that we put lower limit. So let us put upper limit. At a place of x, we will put pi, y is also pi, and z is also pi. So if I put here, we will have pi into pi, pi square sine pi. If I put lower limit, x, y, z, all threes are 0. So if I put here, obviously we will have 0. What is value of sin pi? Yes, sin pi is also 0. So 0 into anything 0, and we will have the final answer 0. So in this way we completed this example. Make a screenshot of it, then we will stop. Thank you. Bye bye.